Let's solve this complex question in 30 seconds. Two vectors of equal magnitude have a resultant equal to either of them. What is the angle between them? The standard textbook method is a huge time sink. You are taught to write out the full cosine formula. R equals the square root of a squared plus b squared plus 2ab cosine theta. Then you substitute the variables, square both sides, cancel terms and solve for cosine theta. That easily takes over a minute. Here is the 30-second shortcut, the 1, 2, 3 root hack. Memorize these instant visual triggers for equal vectors. If the resultant is 1a, the angle is 120 degrees. If the resultant is root 2a, the angle is 90 degrees. If it is root 3a, the angle is 60 degrees. Look at our question. The resultant is equal to either of the vectors, meaning it is exactly 1a. Following our hack, the angle must be 120 degrees. Option C is the correct answer. Notice how the vectors form two perfect equilateral triangles in the diagram. Spot the multiplier, skip the algebra and move on.
Let's solve this complex question in 30 seconds. The horizontal range of a projectile is 4 root 3 times its maximum height. What is the angle of projection? The standard method is a massive algebra trap. You are taught to write out the full formulas for range and height, expand sine 2 theta and divide the equations to cancel terms and isolate tan theta. That is way too much algebra for exam day. Here is the 30-second shortcut, the R equals NH trick. Skip the textbook formulas completely. Whenever the range is related to the maximum height by a multiplier n, simply use this exact shortcut. Tan theta equals 4 divided by n. In our question, the multiplier n is 4 root 3. So plug that into our shortcut. Tan theta equals 4 divided by 4 root 3. The 4's cancel out instantly, leaving tan theta equals 1 over root 3. The angle is exactly 30 degrees. Option A is your correct answer. Spot the multiplier, use the shortcut and save 2 minutes.
Let's solve this complex question in 30 seconds. The equation of a projectile's trajectory is given by y equals root 3x minus 5x squared. What is the angle of projection? The standard method is extremely tedious. You are taught to manipulate this specific quadratic equation to perfectly match the massive standard trajectory formula, factoring out terms to isolate tan theta. That takes time and is highly prone to silly sign errors. Here is the 30-second shortcut, visual inspection. The standard textbook equation always begins with y equals x times tan theta. So you can completely ignore the entire second half of the equation. Just look at the exact number attached to the single x term. Look at our equation in the center of the screen. The coefficient of x is root 3. We put a box around it and drag it over. That means tan theta is simply root 3. The angle whose tangent is root 3 is exactly 60 degrees. Option C is the correct answer. Spot the number, skip the math and bag those 4 marks.
Let's solve this complex question in 30 seconds. Two projectiles fired at the same speed have the same range r but reach different maximum heights h1 and h2. What is the exact relationship between r, h1 and h2? The standard method is a trigonometry nightmare. You have to assume the projection angles are theta and 90 minus theta, write out the individual height formulas, multiply them together and juggle trig identities for 4 minutes just to prove the ratio. Here is the 30-second shortcut, the 4 root rule. For any two complementary projectiles that land at the exact same spot, the range is always exactly 4 times the geometric mean of their maximum heights. Look at the diagram in the center. We have one tall arc and one shallow arc hitting the exact same target point. The mathematical relationship between that range and those two heights is permanently r equals 4 times the square root of h1 into h2. Option B is your correct answer. Memorize this exact 4 root relationship and completely bypass the derivation.
Let's solve this complex question in 30 seconds. A swimmer can swim at 5 km per hour in still water. He wants to cross a river flowing at 3 km per hour via the shortest path. At what total angle with the river flow should he swim? The standard textbook method is a time trap. You are taught to draw complex vector triangles, write out the drift formula, set it to 0, apply the sine rule, calculate the angle with the vertical, and finally add 90 degrees. That easily eats up 3 minutes. Here is the 30-second shortcut, the 3-4-5 triangle hack. For the shortest path across a river, the sine of the angle with the vertical is always the river speed divided by the swimmer speed. That is 3 over 5. Any physics student knows a 3-4-5 triangle means the angle is exactly 37 degrees. Now just look at the center diagram. The angle with the vertical is 37 degrees. The river flow adds a perfect 90 degrees to that. 90 plus 37 equals 127 degrees. Option B is your correct answer. Spot the 3/5 ratio, add 90 and you are done in seconds.
If you found this visual breakdown helpful, you need to put that knowledge to the test right now. Head over to neetapp.in or download the Neet app today. We have chapter-wise, concept-wise and level-wise MCQs from easy to moderate to hard waiting for you to master. Plus, you can take free full syllabus mock tests, grab premium NCRT-aligned study materials and enroll in our ultimate Neet crash course to supercharge your prep. Don't just watch physics, conquer it. Hit that subscribe button, click the link in the description and I'll see you in the next video.